This schematic displays a Tier 4 data center, an environment defined by fault-tolerant power and cooling paths designed for zero downtime. To reach this Tier 4 standard, nearly 5,000 maintainable assets are synchronized to protect the facility. Yet, billion-dollar data centers still experience catastrophic failures that take them offline, despite passing every commissioning test on day one. On the left, we see the handover fallacy. Relying on static documents fails during unannounced audits and undocumented changes. Instead, real resilience requires the circular lifecycle on the right, identifying, maintaining, controlling, and restoring systems in a continuous, evidence-generating loop. Fire protection is a dynamic process. The physical installation is only the baseline. The ongoing ability to definitively prove that a system has been fully restored after maintenance is the true measure of readiness. This is the objective of continuous readiness. Every fire protection function must be governed so that it remains identifiable, restorable, and completely audit-ready throughout the facility's lifespan. The exact moment a fire system is formally accepted at handover is when its highest risk profile begins, as it is now subjected to the complexities of daily operations and human error. Operators classify equipment by asset criticality, where Class A means a single failure exposes a critical data haul. This system query points a failure. Lacking redundant backups, they have a 0% tolerance for any undocumented outage. Proving readiness requires the golden thread, an unbroken digital chain linking code mandates to physical asset tags. It's only complete with locked digital evidence. A pass-fail tick without an actual instrument reading breaks the chain and invalidates the protection claim. This bench shows the prerequisites for maintaining that thread: in-date calibrated instruments, precise lockout-tagout equipment, and compatible staged spares ready for immediate deployment. A computerized maintenance management system, or CMMS, ties these elements together. A technician scans the physical asset tag, which immediately pulls up the correct digital work order, safe isolation boundaries, and the live status of the system. Any maintenance act performed without this thread is a hidden failure, silently degrading the safety of the facility until revealed by a real event. This cross-section shows how technical governance exposes hidden degradation in water-based systems. It allows operators to monitor exact hydraulic performance and verify the volume of the water inventory. For instance, if a reserve tank operates with only a 5.6% margin above its code-required volume, any minor leak removes the facility's safety buffer. In high-density data halls, the focus moves to early warning systems, specifically air sampling detection, or ASD, which monitors the server aisles. Technicians measure transport times using an approved wire burn test below the floor tiles. This proves that smoke will travel through the sampling pipes and trigger the panel within strict code-mandated time limits. Special hazards, such as this clean agent manifold, require integrated testing. The cylinders, the room's structural integrity, and the releasing logic are interdependent. During a door fan test, if the hull holds pressure for only 12.5 minutes against a 10-minute requirement, that margin leaves no room for future structural shifts. Once work is finished, operators execute deterministic restoration. This protocol verifies that the physical valve state, the digital control logic, and the administrative records all perfectly align. The control sequence depends on the situation. While plant maintenance has pre-authorized boundaries, an emergency impairment requires rapid stabilization and immediate containment of secondary hazards. Whenever a Class A system is bypassed, operators must immediately deploy active fire watches and verify temporary protection to cover the gap. A system is functionally restored only when its performance is proven, and the result is digitally recorded by a named approver. Simple pass-fail checkboxes are an operational risk. They record that a task was completed, but they capture zero data regarding system decay. This telemetry dashboard reveals what checkboxes hide. If an ASD pipe's transport time slows from 45 to 53 seconds, it technically passes the 60-second limit, but that 17% degradation is a warning of a blocked pipe or failing filter. The late work risk profile reveals another vulnerability. High compliance numbers in minor supporting systems can mathematically mask overdue maintenance on a critical Class A asset. We see the same zero-margin state in backup power. If a battery test delivers exactly 80% of its baseline, It technically passes, but 80% is the absolute minimum threshold for replacement. To maintain the Tier 4 standard, facilities use a 100% critical gate. If a single Class A asset remains offline or critically degraded, the entire facility fails its readiness audit. Readiness is a binary state. If you cannot prove 100% capability on your critical path, you have 0% protection. A functional test confirms that a mechanical component works. An integrated exercise proves that the human organization can actually respond to a critical failure. Securing this response requires an audit-ready architecture. Every maintenance loop must end with locked evidence, including time-stamped photographs, raw telemetry, and named digital sign-offs. These records are moved into a document vault. Facilities must maintain 5 years of replicated data to ensure they can reconstruct their exact safety posture during an unannounced audit. The technician and the witness share the responsibility of logging as found and as left conditions, ensuring no discrepancy remains in the system. The order in this pump room is the physical result of deterministic restoration. The valves, control panels, and administrative records exist in perfect synchronization. Operational governance takes safety out of the realm of engineering theory and turns it into a measurable physical fact. Returning to the facility overview, the goal is achieved: a data center that is monitored, maintained, and continuously audit-ready. Fire protection remains a measurable life cycle program, verified every day through the golden thread of evidence.